This video is about finding formal charges, and I'll give you some examples in which I'm showing you how to find the formal charges. So the purpose of finding formal charges is to keep track of all the valence electrons that each atom brings when it's forming a bond in a molecule. So after we draw the Lewis structure, we can go to each single atom and we can find the formal charges. So the formula for finding formal charges, it's always the number of valence electrons subtracted from the actual number of electrons close to the atom after bonding. So we basically see that each atom belongs to each group, and then how many valence electron was supposed to bring, and then after bonding, how many electrons did it actually bring. So as an example, we can take a look at CH4. So you have to first draw the Lewis structure of CH4 and then look into each atom individually. If you don't know how to draw the Lewis structures, I've made another video that I explain step by step how to draw the Lewis structures the easy way without making any mistakes. So if you want, I'll tag it over here and you can take a look at it to find the best way to draw the Lewis structures. So after you draw the Lewis structure, we can take a look at each individual atom. For example, let's say carbon. So carbon, based on the formula, we said we have to first find the number of valence electrons. So because carbon is in group 4, it has 4 valence electrons. And then second, we have to subtract it from the number of electrons close to carbon after bonding. So if we take a look at carbon, the electrons close to carbon will be 4. So each bond is made from 2 electrons. So only the electrons closer to the carbon are counted. So we're technically counting half of each bond, the electrons of half of each bond. So 4 minus 4 electrons would be 0. So the formal charge of carbon is set to be 0. We do the same thing for hydrogen. Hydrogen belongs to group 1, so it has 1 valence electron. And then after bonding, if you take a look at the number of electrons close to hydrogen, there's only 1, so subtracted from 1, which would be 0. And then the other 3 H's are exactly in the same situation as the first hydrogen, so they all will also have a formal charge of 0 as well. Let's take a look at another example, CO₃² So first step is to draw the Lewis structure. After drawing, we can take a look at each atom individually. So this oxygen belongs to group 6, so it's supposed to have 6 valence electrons. Minus, after bonding, we see there's 7 electrons on oxygen's side. So minus 7 would be minus 1. The oxygen on the left is exactly in the same situation, so it's going to be minus 1 as well. But then carbon over here, it's in group 4. So 4 valence electrons minus, after bonding, it will have also 4 electrons on its side. So it will be 4 minus 4, which is 0. And then the top oxygen belongs to group 6, so 6 valence electrons. Minus, after bonding, it has 6 electrons close to it as well. So the formal charge is 0. Another example would be O3 or ozone. So this is the Lewis structure of ozone. Now there's 3 types of oxygen. One of them has a double bond, one of them has a lone pair on it, and the other one has a single bond on it. So let's take a look at each one individually. So this oxygen group belongs to group 6, so 6 minus, and then after bonding, there's 6 electrons close to it. So formal charge of this one is 0. The oxygen on the right belongs to group 6, so 6 valence electrons minus. After bonding, it has 7 electrons on its side, so the formal charge is minus 1. The top oxygen is group 6, so 6 valence electrons minus. There's only 5 electrons around it, so 6 minus 5 would be positive 1. So these are the formal charges. One thing to note about the formal charges is that the sum of all the formal charges should be always equal to the overall charge of the molecule. So for example, CH4, it was a neutral molecules and all the formal charges were 0. So if you add them up, it adds up to 0. Or in the case of CO₃², there's a overall charge of minus 2. So if you look at all the formal charges, 2 things had a formal charge of minus 1 and the rest of them were 0. So it adds up to 2 minus as well. And then for O3, we had a plus 1, a minus 1, and a 0. So when you add them up, the overall charge is 0. And that's exactly the same as the sum of formal charges too. So it works out well. So this is a good way to check to see if you've done the formal charges right. Let's take a look at a few other examples, like PF3. So first step, draw the Lewis structure. Then let's take a look at each phosphorus first. So phosphorus is in group 5. So it has 5 valence electrons minus, after bonding, another 5 electrons close to it. So it's just 0. Fluorine belongs to group 7. After bonding, there's 7 electrons close to F. So it's 0 as well. And then the other two fluorines are exactly the same, so they will be 0. Another example, NO3 minus. So we draw the Lewis structure. Oxygen, this one, it belongs to group 6, so 6 minus. And then after bonding, there's 7 electrons around it, so -7, which is -1. The left oxygen is exactly identical, so it's -1 as well. Looking at the oxygen at the top, belongs to group 6, so 6 minus. And then it has 6 electrons around it, so it's formal charge of 0. And then at last for nitrogen, it belongs to group 5, minus 4 electrons after bonding, so the formal charge is +1. So here is another example that you can see that the sum of formal charges are exactly -1. So you have 2 oxygens with a -1 and a nitrogen with a +1, so they add up to be -1 as well, which is the same as the overall charge. And then the last example would be SF4. So here's the Lewis structure for it. Looking at sulfur, it belongs to group 6, so it has 6 valence electrons. After bonding, it also has 6 electrons close to it, so formal charge is 0. And then looking at fluorine, it belongs to group 7. And then after bonding, has 7 electrons on its side. So again, the formal charge is 0. And then the same goes for the other fluorines as well. All right, so this was the end of this video. The video that I suggest for you to watch next is a video I have about formal charges rules and finding the most stable structure using formal charges. So I'll be tagging it at the end over here as well. And that was it for this video. Thanks so much for watching. If you enjoyed it, please don't forget to hit the like button and subscribe to watch more tutorial videos. Hope to see you in the next video.